Hi everybody, welcome to the talk on Tekton, CI/CD pipelines and Kubernetes. Thanks for coming out. How many people here have used Tekton before? Anybody? One or two? All right, how many people have used Kubernetes? Quite a few people, great. How many people this is your first time at an All Things Open? A few people, what do you think of it? Pretty cool, right? So I'm going to try to remember to stay in front of the podium and talk here so you can hear me. If I start to wander around, which I do sometimes, please just remind me to get back in front of this. We've got folks on Zoom as well. So my name is Brent Laster, and I have a training company called Tech Skills Transformation, and that's where we're bringing you the presentation today. My day job, though, is as an R&D DevOps Director at a company called SAS, just down the road from here. Some of you may have seen that, been out to the booth out there. If you haven't, I encourage you to stop by and check it out. I do a lot of global training, though, just to kind of keep my, my hands and my mind engaged in what's going on with the current technologies and things like Kubernetes and Git, CI/CD, pipelines, all those kinds of things. Have a couple of books out there. There's some information on the slide here if you want to connect with me on social media. Always happy to make new connections there. Real quick, just shameless self-promotion here. Do have a couple of books out there. One on Git. If you are new to Git or want to learn some advanced stuff, maybe check this out. Of course, I'll say there's lots of free and open source or free options out on the web too for learning Git as well. But I'm obviously kind of partial to this one. I think it's a pretty good representation of the spectrum of Git from beginning to advanced users. Also have a Jenkins 2 book for CI/CD and pipelines as code. This goes to the idea of being able to use the more modern features of Jenkins to create actual pipelines in the same way you would write a script to be able to do your things like your build, deployment, similar things we're going to talk to as in Tekton today, but doing it in Jenkins. Newest book coming out probably June of next year. If you're interested in GitHub Actions, the new automation framework in GitHub. First 3 chapters of this one are available on the Riley site. If you've got O'Reilly Access, you can get free access to that. We'll have a couple of other chapters coming out later on. One other thing I wanted to mention was just as a follow-up, if you want an additional resource to look at, I do have a report on O'Reilly. Again, this is free if you have an O'Reilly account that you can go into and look at that describes the things we're going to talk about here and goes into a little bit more depth on them. It's like about, I think, 25 pages or so. But a follow-up for Tekton if you want to have an additional resource to look at as well. Some things in O'Reilly training, if you search for my name on there, you'll find a couple of things depending on what we're offering at any point in time. But let's get to the thing you came for today, which is talking about Tekton. So in the next 41 minutes or so, we're going to cover what Tekton is. What is this strangely named thing, and what does it do for us in terms of CI/CD, in terms of relationship to Kubernetes? How does it work? I'm going to show you some pictures, some animations to help you understand. I believe when you're trying to learn something like this, we can talk about a lot of the concepts abstractly and stuff, but if I can show you some animations and show you some pictures and the way things flow together, I think that's a better representation of it. We'll talk about some of the components of Tekton, things like task. Tasks are sort of like you might think of a job or a project in a CI/CD process, something like pulling down source code, doing your build, doing those kinds of things there, doing your tests, those kinds of pieces. And then we'll see how tasks are actually combined to go into pipelines, Tekton pipelines. That's the larger CI/CD pipelines, running a set of tasks together to take your things from source code changes all the way through to presumably deliverables that you could make available to your customers. And then we'll talk about Tekton triggers. So Tekton triggers here refers really to the CI component of what we talk about with CI/CD. In the CI/CD use case, we think of CI as continuous integration. That is being able to detect that a change has come in or being able to be notified that something has changed, and we want to take that change and then kick off a run of our CD, or continuous delivery pipeline. Now, out of the box, you'll see Tekton comes as Tekton CD, which is really just a continuous delivery piece of it. Tekton triggers actually adds that CI component. We'll see how that all fits together as well. So what is Tekton in general? They call it Cloud Native CI/CD. Now, Cloud Native CI/CD refers to the idea that we can make our pipelines run as native objects on Kubernetes. That's really what Tekton's claim to fame is, that you are able to create custom resources, custom objects in Kubernetes that will do the CI/CD process for you. If you think about it from the standpoint of both the popular platform of the day, Kubernetes, and also the popular way to create and build software, CI/CD, Tekton really combines those in one piece. So it's the Kubernetes native way to implement CI/CD and pipelines. It's also open source, part of the continuous delivery foundation of products, and it's implemented using custom resources in there that you can do with Kubernetes manifest. So if you are already comfortable with Kubernetes and you already understand how things flow in there, it's an easy transition to get to using the Tekton objects. I won't say it's not complicated, but it is easy if you understand how to use Kubernetes manifest. The other nice thing about it is it actually runs on Kubernetes infrastructure. You're using Kubernetes objects to run in a Kubernetes cluster. So if you think about it from the standpoint of being able to do things like scaling, if I want to scale up, I can add another node to my cluster. I can add more resources in there. I'm not having to go through some other application like a Jenkins or something in there. I can run this on Kubernetes, so I can take advantage of all of the tools and all the functionality that I already get out of Kubernetes to leverage in my CI/CD pipeline. And this pretty much just says some of the things I just went over. It runs natively on Kubernetes, and that really offers you a separation of concerns between the definition and implementation. What we mean by that is I can define my CI/CD pipeline using the Kubernetes objects, but ultimately what happens is it's going to run images, it's going to run containers that will do the work for me. So I can have the functionality built into the containers, and then I can have the Kubernetes objects around it. So I can define my flow using Kubernetes and then define the actual functionality using the containers in there. So it abstracts out that underlying implementation so that you can choose containers and images to do the kinds of builds you want, do the kinds of testing you want, and so on. It has a standardized on Kubernetes, as we said, and it also works with other tooling like Jenkins. Jenkins X, if you haven't heard of that one, Jenkins X was an attempt to take, kind of evolve the Jenkins family of products and be able to generate Tekton pipelines on the back end. It hasn't got as much of a press these days as some of the other things, but it is a nice way to, if you know Jenkins and you're familiar with that sort of environment, to kind of tie it in to ultimately getting to Tekton pipelines. It does things like automatically create cloud-ready pipelines for you, set up different deployment levels in there, prod, test, all those kinds of things in there. Scaffold, native, many other popular CI/CD tools, and like any good open source project these days, it has an extensive library of reusable pieces for any of the common tasks that you want to do. So, to be fair, what are the disadvantages of Tekton though? The main disadvantage in there is that it can be complex to set up and maintain. By that I mean that if you're used to, for example, going into a Jenkins environment and doing a simple click and point or click and select different options in there, that sort of thing, Tekton requires you to use these custom resources to declare the manifest for Kubernetes, to be able to have all your stuff in images and tie it all together. So it gets, in the same way as with anything in Kubernetes, the YAML that you have to specify and create around this can get pretty complex for a simple task. It only does CD out of the box. As I mentioned, out of the box, it's Tekton CD, it's continuous delivery. It's this idea of defining the pipeline, defining the pipeline and the task, and then being able to run those, but it doesn't have the CI piece attached to it. So the CI piece comes from the triggers piece, and I'll show you how that works along the way. And again, it requires a little bit of a mind shift from typical Kubernetes model. If you think of Kubernetes, in a lot of cases, what we're thinking of is we have something running continuously in Kubernetes. We start up a deployment, we have the pods running, we have the pieces that are going. And part of the job of Kubernetes is to actually be able to say if something stops running, if something fails, to restart it, right? In this case, we're talking more about the things like a Kubernetes type of job, if you're familiar with that construct, where we're doing run through and finish. Run through our pipeline, execute through the flow, produce what we need to, and we're done. So there's a little bit of a mind shift there from the typical use case of Kubernetes. So the basic elements of a Tekton pipeline, we start out with the task. The task could be compared to a project or a job, some element that you want to, or some action that you want to accomplish in terms of like a build, a test, that kind of thing. Generally, when I talk about this with people, I say the granularity you kind of think about here is when do you want to know success or failure? You know, do you care about success or failure at the build job level versus a build and test? One does a build and test where both things might be in there, and then if it fails, then you don't know which part actually failed in there. So it's the kind of a project or job you might equate to in something like Jenkins. So tasks have steps. And steps have different attributes, different properties, such as an image to run. In Tekton, when we talk about running a task, we're actually talking about spinning up a pod. We're talking about spinning up a pod in Kubernetes, and then each step in a Tekton task corresponds to a container. So you have a container that goes off then and runs the particular part of the step or does whatever that step is supposed to do. So you have an image that you specify so that Tekton understands which thing you want to run, and then the action happens in the image. We have commands that we can use, scripts. In other words, if we're using like an Ubuntu image, it's a basic operating system image, to say this is where we're going to do things, then we can supply that script or that command to actually do the actions. We have parameters, workspace, working dir, results. You get the idea. These are all the kinds of things you would need to have to do some sort of a process or an action in a CI/CD world. So tasks are made up of steps, and then we have this little bit of a mind shift here in terms of thinking about where we might think about normally a CI/CD pipeline would be kicked off and run. We actually, because we're in a Kubernetes declarative model, we have to declare a task run, a Kubernetes custom resource called a task run that is then going to point to our task and actually cause it to run. Now the task run can do things like, say, if you have a working dir workspace that you have in the task run can say, okay, we're going to map that workspace to a particular PVC, to a particular disk area out there. So it can kind of fill in the blanks, fill in the parameters for the task. But we have to declare a task run object in order to get the task to execute. Again, think of it from that standpoint of Kubernetes being declarative. So we declare a task run, and then pipelines in Tekton are made up of multiple tasks. Again, tasks have steps, pipelines have multiple tasks. And then, not surprisingly, you have to declare a PipelineRun object, a custom Tekton object called a PipelineRun, to actually go and kick off the pipeline, which will then, in fact, kick off task runs, which will kick off and run the task in there. So we have these different elements in there, which are all available as custom resources when Tekton is installed. So the way that this works, here's an example task, and I'll just highlight a couple of points on here. So the most basic unit of execution in the pipeline is a task, and this is done via a pod. So a task is ultimately going to result in spinning up a new pod in Kubernetes and then have containers to run the steps. So you can see here at the, I guess my laser pointer isn't showing up in there, but if I look at this part at the top, I have an API version, Tekton Dev. So it's just a Kubernetes custom resource. When you run Kubernetes, when you run Tekton, you install a Tekton controller. That is the controller piece, which is the piece in Kubernetes that understands how to take the manifest, the definitions that you supply in YAML, and make those objects be instantiated in the Kubernetes cluster. So the Tekton controller that you install understands how to take something like a Tekton task and be able to spin up a task object in Kubernetes. There's also then, let me get back here. There's also then the steps you can see here. The steps in here, like hello world 1, hello world 2. These are the actual steps inside the task, and what they are going to be implemented as is just a set of containers within that pod. You can see here we have the image definition that we're going to pull down for that container to spin it up, run Ubuntu on it, and then we have a command here that we're going to run based off of having that Ubuntu image loaded and running in the container. Steps is looking at a little bit closer here. This is basically just a little bit of a zoom in based on what we've just talked about, but it's an atomic operation in a pipeline. It clones down a repo, kicking off a build, any of those kinds of things. Now, of course, you have the same overhead with anything in Kubernetes. You're going to have to get the image down, start it up, all those kinds of things. But again, the advantage here is that you are running this as a Kubernetes object. So you're not dependent on some kind of a third-party application trying to be deployed inside of Kubernetes and then trying to integrate that and make sure it all fits in there. So you have all the ways you can scale Kubernetes and stuff. You can now scale your CI/CD infrastructure if you're using Tekton. So creating a task, what does this look like? Like I said, I like pictures and animations to try to help explain things. So in a Kubernetes cluster, if we want to use Tekton, we first have to install Tekton Pipelines, a couple of pieces there. There's a Tekton command line, there's also a dashboard, and so on. But you install the Tekton controller. Again, the controller is just the piece you're putting in Kubernetes so that Kubernetes understands if you ask for a particular type of Tekton object, this is what it looks like, this is how it's going to behave, this is how I manage it in the general sort of startup, delete, restart, whatever in there. So we have the Tekton controller. We then can have a Tekton manifest, and we can simply do a kubectl or kubectl apply in there. And then the Tekton controller says, you've asked for a task. Great, I'll spin you up a task. It looks like this with the various steps as you've asked for, and with the images that you wanted in there, and go on our way. Now note that nothing has happened at this point yet, other than we've defined the task into Kubernetes. We haven't yet caused it to run. That's where we would bring in the task run. We'll talk more about that in just a moment. But there is also a command line interface called TKN. Any of the tools of Kubernetes these days, we usually have a command line interface which is focused on being able to deal with the custom resource objects, the custom objects that you create for that particular application. So the TKN command line allows us to do things simpler with tasks or with pipelines or with any of the kinds of things that we would normally work with in Kubernetes. You can just as well, though, you can create these kind of definitions, you can apply them with kubectl, so you can use the native Kubernetes interfaces like the command line, but you can also use the custom Tekton command line. There's also a Tekton hub, though, and so the Tekton pipeline or the Tekton command line makes it easy, for example, to install things, to install tasks and such from the hub. Think of the hub as this shared repository of tasks that you can choose from. So the command line makes it easier to install things as well. But regardless, what ultimately happens is you get that task in there that the controller spins up what you want and you have it ready to run in there. Not executing yet, but you have the definition spun up and ready. The Tekton command line, we mentioned that just now. This is an example of, or this is a list basically of the most common commands you would have in there. You can see commands are around things like the task, the pipeline, triggers we'll talk about in a little bit, but the kinds of objects. So the command line just gives you that extra simplification in terms of being able to work more directly with the kinds of objects that we define for Kubernetes with Tekton. It's a more direct way to work with it, but again, you can also just use the standard kubectl and use that to apply and manage the objects as well. So running a task from the command line. So you can either run a task in there once you define it, by doing a kubectl apply-f in there, or you can do like a Tekton task start. And here we're using a git clone task to get that. And you can see that if we do it from the command line, this is a little bit of an elaborate example, but it's basically saying, here's all the parameters that we have for the predefined tasks that we called git clone. These are all the values we'd have to pass into it. So it's probably going to be easier just to define it in a YAML file and do it that way, but if you wanted to, you could use the Tekton command line to do it, passing all the parameters in. Now Tekton, like as any good open source project or anything these days that's popular to use, has catalogs or has a way to get predefined applications, plugins, whatever you want to call them. In this case, we're talking about tasks, reusable tasks for Tekton. Tekton user provides catalogs of reusable tasks. Now right now, this is stored out in GitHub with the task organized by subdirectories. So if I wanted to do a git clone operation, for example, in my pipeline in a task, there's a git clone task that's available to us if I go out to github.com, Tekton CD catalog, and I can go and pull that down and I can use it right away in my pipeline. I don't have to create it myself. They'll have a README, they'll also have a Kubernetes manifest to make them readily usable. Again, the advantage that if you understand Kubernetes and you understand how to use Kubernetes manifest, this is a pretty easy transition. You don't have to learn yet another application in there. There's also some OpenShift specific pipeline pieces out there at GitHub, or actually at this longer URL that I have on here. OpenShift pipelines, you know, Red Hat and OpenShift, they have a CI/CD pipeline framework which is based on Tekton. So that's one of the main users, consumers of Tekton these days is the OpenShift pipelines. If you ever get into working with that, you'll be using Tekton in terms of the implementation. The Tekton Dashboard, we have an interface you can spin up with that. You can have a separate available web UI with pipelines and triggers. Basically just what you would expect. It's already set up to be able to segment off, allow you to look at the different custom objects that you have there, the pipelines, the task runs, all those kinds of things in there in a web browser. There's the Tekton Hub. I mentioned this earlier when I talked about the Tekton command line being able to install things from the hub. So the hub is designed to allow users to share tasks and pipelines as well. This is from Red Hat with support by the Tekton community. And you can go out to hub.tekton.dev, not really easily seen there, but hub.tekton.dev, and there's a lot of certified tasks. These are tasks that people have contributed, that have been vetted in some manner, and Red Hat has said, okay, these are worthy to be on the hub. Red Hat does a lot of things with different hubs, of course. The Tekton is no different. And since they have a big investment in the OpenShift pipelines using this, it's very convenient to have the task out there to go to pick, or the hub to go to pick out the different tasks. Let's take a quick look at one of the kinds of tasks you might see out there. And I'll try to zoom in on this if I can. So this one is one called Kaneko, at least that's how I say it. Maybe it's Kaneko, I say Kaneko in there. And even zoomed in, I realize it's hard to see. But basically, Kaneko is a task that allows you to basically build the equivalent of a container image without a Docker daemon running. It runs all the commands for the image build in user space in there. So it's a convenience, especially when you're working in Kubernetes, to be able to build those images there without having to rely on Docker. The point about this, though, is you see there's a Kaneko task that somebody has defined for Tekton users to use. And if I can zoom in on this part, you'll be able to go out, you can go out there, you can find the Tekton task, you can find the different instructions about it, you can find the parameters that you need to supply for it, you can find the definition of it in there as well, all the pieces. So you have a set of ready-made tasks for a lot of the kinds of things that you would need to do. Let's see if I can shrink this down. There we go. All right, so this is just a quick sort of view of a task to kind of break it down. When I do these kinds of presentations, I like to supply examples and kind of at least expose you to what the different pieces are in there. So this is a Tekton, this is the Kaneko task, the YAML definition, the manifest itself for it. So I'll show you the pieces here. Let me see if I can actually figure out how to zoom in on this the right way. Oh, goody, the battery's about to die. All right, so we've got the task in here, the Kaneko task. We've got then the specification, the Tekton Beta 1 API version. We've got the Kubernetes version in there. We've got the pipelines version in there. We've got the tags and so on. Now I'm going to grab my power cord real quick here so we don't lose this. Give me 1 minute. Just to make sure. All right, sorry about that interruption, folks. All right, so the Tekton, the Kaneko task here, we've got the Kubernetes version up the top there. This is just a standard Kubernetes custom resource, its own API. You then got a description of it in there. We've got the parameters passed into it. So when you're getting a ready-made task or when you're defining a task in Tekton, you're going to have the parameters you're going to pass into it. For this case, for things like with Kaneko, since it's concerned with building container images, we have things like the Docker file we're going to use, the context, and so on, the standard kinds of things. If we go back, zoom back out here, we also have the workspace details down here. Now the workspace, and we'll talk more about workspaces a little bit later on, is where we're going to obviously do the action, the disk space that we're going to be doing operations in. Now when we talk about workspaces here, these could be to a simple type of what we call like an empty dir, a temporary space we write things into and it goes away. It could be a PVC that we pass in as well in there to do things with. The workspace details, as far as the specifics, don't have to be defined in the task itself. They can be passed in from the task run. This is just providing the set of things, basically the template, the functionality there that we are making reusable so we can pass in the parameters, the workspace, and so on for that. Then we have also, going a little bit deeper into it, we have a string, that results string emitted by the task. So when we talk about Tekton and we're actually running things in Kubernetes, one of the things it does is it allows us to output information. Now, the way a lot of these pieces work in terms of outputting information in there and working with things is in the container, there's file systems that are mounted in there to write stuff out to record results, do those kinds of things. And we'll talk more about that in just a few minutes. But we have the results that it can write out. In this case, since we're building an image, we're going to write out the digest, essentially the SHA-256 value of it. Then there's the steps. Here's a definition of a step for Kaneko to build and push. You can see it has places to get the working dir, the builder image, things that can be passed in. This task definition can have these values passed in, like from the task run. It could be from the pipeline or the pipeline run, any of those higher kinds of objects in there. So we have then the different things that we're going to pass in the Kaneko task. We also have the image spec, one of the image specs that we're using here for this to pull down the image and the command to run. Let me zoom back out on that. Command to run in the image, and so on. You get the idea. Same sort of thing is we have steps in there that we're going to execute. We have an image that we pull. We have commands that we run based on that to do the particular functionality. So parameters in there, when we pass in parameters to a task, we use that to make it reusable, of course. We can have values that are get passed in by any of those higher level objects. We can have default values in the task if we want our task to not have to worry about having something passed in. But we can also pass in the parameters from the task run when the pipeline or the pipeline run, and we can reference it in the task itself. The workspace is where we provide that file system path where they can read, write data. It can usually map to a PVC. And there's additional functionality that's been in the works for a while to kind of allow each pipeline run to create its own PVC and so use its own volume. In other words, you're not having to set it up separately so that it can do it dynamically as it runs. When we talk about results in there, it's a string that a task can write out. It's viewable by users, can be passed to other tasks in a pipeline. It's a way we can pass information or feedback out or pass it into other parts of the pipeline. Example might be like the generated build ID emits a randomized ID, or as we saw, Kaneko emits an image digest there. What actually happens is it corresponds to a file inside the container. So inside the container, when we're working with Tekton, Tekton is mounting these areas in there, like a /Tekton results directory, where it's going to write the information. So there's not a lot of magic going on here. It's really just writing the information into that mounted space inside the container and keeping track of things like results that way. The task run. So we talked about declaring a task. So the task says, this is a template for a thing I can do once I am started. The way we start the task running is a task run object. Now this is a little bit of a mind shift from the standpoint of if you click on something in Jenkins, for example, or you have something that kicks it off and initiates it and it goes off and run. We have to define a task run object. Remember, Kubernetes is the declarative model, right? We declare what we want. Kubernetes then instantiates the objects and gets them going in the cluster for us. So we declare a task run object here, and you can see that it has a couple of pieces in it. It has the basic Kubernetes info, just another Kubernetes custom resource. It has a task reference, meaning the task that it's going to refer to is actually going to run. And then it has parameters to pass to the task. So this is the way we actually tell the task what we want it to do, what we want it to operate on. We pass in the information to it, as we call it. And then a workspace there that it can do its work in. So creating a task run, similar to the same ideas before. We can use either the Tekton command line, or we can apply a manifest. And we just do a kubectl apply, for example. We get a task run. It creates a task run object. And that then causes that task to be executed in Kubernetes. What Kubernetes does is it says to create a task that is a pod, or create a pod for that task, and then create containers in there that correspond to each of the steps. So if we look at how tasks correspond to pods and containers, here's a definition of a Tekton task in there. And you see a couple of steps in there. If we were to run this with a task run in Kubernetes, we would see that we have a pod corresponding to the task, and then we would have separate containers that correspond to each of the steps in there. So pretty straightforward. Now when we move out to a higher granularity, we talk about the pipeline. Pipeline is essentially just a collection of tasks. So the pipeline has the basic Kubernetes info, and I won't try to zoom in on all this now for the sake of time. Different parameters that we're going to be passing in. So at the pipeline level, we're going to have a larger set of parameters because we're passing them all to all of the tasks in there. Then we have the workspaces, the different tasks that are involved in there, and the different task ref. So the pipeline can define a task name, which we can then basically reference or point to the underlying task in there and pass in parameters for that. So for creating a pipeline, similar story as what we've seen before. We have a pipeline manifest with the definition of the different tasks involved. It creates a pipeline object in definition with the task definition with the different steps in it. And so then we've got that ready to have a pipeline run to actually be able to spin that up. Now, there is one thing I'll point out here in terms of there's a thing that was in the Tekton V1 Alpha 1 API called Pipeline Resources. That was intended to encapsulate things like a Git resource, reference to a branch in Git, sort of in that, and for those kinds of things where you had a resource you were trying to access. They have since deprecated those and have replaced it with task, the more declarative model of what you want to do. So whereas there was a pipeline resource for a Git object before, there's now a Git clone task. I mention that only in the sense of if you were to look at some of the older Tekton pipelines, you might see references to the pipeline resources. Running a pipeline from the Tekton command line, pretty much the same thing as we said before about task. We can apply a PipelineRun definition to say this is what we're supposed to pass into the pipeline and start it running, or we can use the Tekton command line and try to pass all the parameters on the command line. This is a PipelineRun definition. Again, pretty straightforward, basic Kubernetes info. Service account. So Tekton authentication has a couple ways to authenticate. Typically it's by secrets. There's a basic auth secret where you can use standard sort of auth things, and then there is the also an SSH secret you can do. So basically you create the secret, you tie it to the service account, and then the pipeline runs under that service account. This is a reference to the pipeline. We want this PipelineRun object to start with. These are parameters to pass into it and the workspace as well. And here again, at the runtime, this is where the pipeline run or the task run, if you're running a task, this is where it actually is going to map what we're actually mounting, what we're actually using the PVC, for example, to what is used in the task or pipeline. So that kind of separation of concern. We don't have to define, at the time we define a task or a pipeline, we don't have to define all the specifics of how it gets to the data and pieces. We can supply that when we go through the pipeline run or the task run. This is, again, just a simple example, but when we have the pipeline run object, we apply that. That then basically spins up task run. So a pipeline consists of tasks. So the pipeline run spins up task runs and runs them then in the pipeline. Now, tasks are going to run by parallel, or run in parallel by default. There are ways in Tekton, there's a run after clause where you can actually use that to say I have to run after one task, so you can be sequential. But the end result is the same. Your pipeline pieces run as containers with pods in there. I'll skip the demo I'll talk very briefly about it just very quickly here. This is an example of one of the ways you could use Tekton kind of in almost like a GitOps way. If you could find a pipeline, for example, something that's going to pull down some manifest for you and some image definitions. So in this case, I have a little app that I have a database image and a web image as well with it, a web piece and a database piece. And I have a pipeline that's basically going to go grab the manifest, the Kubernetes manifest for deploying this, build updated images, update that, and then actually deploy it out to the cluster. So the basic flow with this is it's going to call a git clone task to get the pieces down, a built-in or a predefined task in Tekton from the Git repository. It's going to then pull down like some Docker files in there and the Kubernetes manifest, and then the building the images can be done with the Kaneko Tekton task. So we could go and build new images there, and Kaneko also has a way to push it out to a repository. So it pushes it out to a repository and do the same for the web image. And then we can have a custom task, meaning one that we write ourselves, which goes, for example, gets the Kubernetes manifest, updates it, plugs in the updated image versions. We built new versions of those images, we plug those in, and then we can also have it deploy out to the Kubernetes cluster. So that's an example way if you are updating your images that you're using for your product and you want to have like a Tekton pipeline in there that's going to deploy it out that way. One example of how it could be done. And I'll skip through this. So Tekton CD and CI. Out of the box, as we said, Tekton is CD, continuous delivery only. Pipelines should only have that CI component, that way to detect when something has changed and know that they should kick off a run of that. So far, we've just talked about invoking the pipelines manually through the PipelineRun, but we would want to have it be able to be executed or driven off of an event like a pull request in GitHub. So in order to do that, they've come out with a component to Tekton called Tekton Triggers. Tekton Triggers is a additional add-on component of Tekton. I know there's a lot of words on the slides here, but the essence of this is that it sets up a service that's going to be listening for events. When you install the Tekton Trigger controller, it's just another controller in Kubernetes. You have then a service that you define that's listening for these events coming in. When these events come in, the Tekton Triggers has a template, basically, which says, we're going to create a pipeline run, we're going to instantiate a pipeline run object based off of the information we got in from the system. So there's a way with this to do a trigger binding. Basically, we take the payload that came in, we then pick out the pieces that we need to plug in as parameters for the pipeline run, and then we're going to create a pipeline object to run that. So let me kind of show you, I'll skip some of this for the sake of time, but I'll jump to this part. This is on the trigger, a resource template, a trigger template here, or pipeline run template rather, versus an actual pipeline run object. So on the left side of this, this is what we would have as set up with the Tekton triggers to be filled in when information came in. And you can probably, even if you can't read it from here, you can see pretty easily, it maps very closely to an actual pipeline run object. So the idea here is if we have our pipeline defined in Kubernetes and we have the different steps and the images and all the pieces in there set up, then when we want to add in the CI piece, we add in the Tekton Triggers controller. Again, just a controller that understands how to take specifications or manifest for Tekton triggers and spin those up in the cluster. So the the trigger components are a service and an event listener and a trigger binding and trigger template. So I'll show you how this works. Basically, if we have something like a Git repo, let's say that's going to be our triggering event. We have a pull request in there, and we do that pull request in the Git repo. We then have a payload, meaning like a webhook or something that sends us over the information. It goes up to the ingress coming into the cluster, goes to the service that's listening on that port for events with the Tekton triggers. Now we get into the trigger binding part. And the idea is that I have a template for a pipeline run that can be filled in from the information that I extract out of that payload. So if there's things like the Git branch, the SHA-1 value, those are repository, those may be the three pieces of information that I'm interested in from that payload, from that event that came in, and that I need to pass on. So basically, the trigger binding defines a set of information that came into this, that came in with the payload, that says these are the pieces of information that I want to pull out, that I want to use, and I want to define, and I want to grab from that. It then plugs those in to that trigger template. So it plugs it into that pipeline run template, for example, which then allows it to construct an actual pipeline run object, which then kicks off the things that we saw before, the task runs and the pods and the containers and so on. So this trigger, Tekton triggers, is what allows us to have that full CI/CD workflow. It adds on the CI part of the process there by saying, I'm going to sit here and listen for events coming in, grab the information I want out of it, plug that into a template, and then create a pipeline run off of that to run my pipeline. So like I said to start, kind of a little bit of a mind shift here in terms of how we do this versus traditional Kubernetes. Last part, a couple of integrations that are out there. If you're working as a developer, working with dev tooling in Tekton, there is an extension for Visual Studio Code. There is an extension for IntelliJ. There's a client plugin for Jenkins, and that allows Jenkins to interact with Tekton pipelines on a Kubernetes cluster. All right, I think that's it. Looks like we're about out of time anyway. Do we have time to take questions or not really? Okay, I think we're out of time. If you do have questions, feel free to come up after the presentation here. I'll be here for a few minutes and happy to talk with you about that. Thanks, everybody. Appreciate it.